So we are going to solve the lead code question um, 540 single element in a sorted array. So there would be many possible ways to solve this question, but could be making a hash map and storing, and then the element that occurs only once we could simply return it when otherwise we there's also space optimized solutions such that we could iterate it, and once we reach the element who only occurs once, we simply return it. But here we are asked to solve this in O of log n and O of 1. So in O of log n comes the mind thing should think binary search. So we are going to use binary search here. So firstly, let's define int left is equals to 0 and int right is equals to nums dot size minus 1. Rather, let's go on and define n for it. Int n is equals to nums dot size. So this will be right is equals to n. So let's do while left lesser than equal to right. So there could be the case that the array only has one element. So we simply have to return if n is equals to 1, return nums dot 0. This will be the element occurring only once. So otherwise it could be the case that therefore we need to define a int mid is equals to left plus right divided by 2. So the first case could be if mid is greater than 0 and the nums dot mid is equals to nums dot mid minus 1. So if this is the case, we could come across two possible scenarios. One of which could be if mid minus 1 mod 2 is equals to 0. In this case, for example, the in the first example, 1 1 2 2 3 3, the index of the current word would be 4. That is the element 3, and the 3 is equals to 3. Therefore, it would be true if mid minus 1, which is 4 minus 1, 3 mod 2 is equals to 0, which is not true here because 3 is, therefore, we could simply do this left, sorry, right is equals to, no, hmm, left, hmm, 0 1 2 3 3. If this is true, this is not true here. So, hmm, so yeah, we could define it as left is equals to mid plus 2. But as this case is not true here, we could simply do else right to mid minus 1. So what it does this, sorry, right is equals to, uh, we could be sure that as mid and mid minus 1 are equal, we could do mid minus 2 was the current mid and the mid before it. Can't be it. So, and mid plus 1. Suppose if it was not 2 and it was 4 4 here instead of 3 3, it would have been different. So, yeah. Um, Another case could be else if mid lesser than equal to sorry, mid plus 1. We need to impose the check so that it doesn't run out of the loop. And nums mid plus 1 equals to nums mid. Then what could we do is if mid mod 2 is equals to 0, then if the current mid is 0, that means, for example, um, uh, it is at index 4, then the elements could be 0, 1, 3. So we could be sure that the element that occurs once will be present in that. So we could do right. You have to shrink it from into that. So right is equals to mid minus 1. Else, if it is not true, so it would the mid is currently odd. So odd means, for example, the mid is 5. So elements would be 0, 1, 2, 1, 2, 4 on the beginning, and the remaining on the right, which means the odd elements on the right. So we could skip the current mid and the next mid, which would be right, sorry, left is equals to mid plus 2. Else, if it is not the before element or the right in the previous element, we could simply do return nums dot current mid, which means it is the element we are looking for. Two corner cases could be that the first element is the element we are looking for, that is only occurs in the or the last element. So we could do two checks. If nums dot 0 not equals to nums dot 1, to do return nums 0. Else, if nums dot n minus 1 not equal to nums dot n minus 2, we could return nums n minus 1. And else, for just this scenario, we could simply return, because it has to return something. So return 0. Let's check if it's working fine. There's an error. Okay. 10, 0, 0. We have imposed a check now. Nums. Okay. So nums n minus 1. We are returning nums n minus 1. That's everything fine. Else return num dot made. Okay. Made is greater. Made is equals to mm, nums made plus 1. Right is equals to, this should work fine. Right equals to n minus 1, yes. Okay. Seems to be the issue. Expected is 10, output is 0. So it is not getting to the correct answer, which is 10. The current mid will be 7. Checks for equals to 0. This if mid minus 1 left is equals to mid plus 1. We're doing that. Right is equals to left is equals to mid plus 1. Let's see. So I think I've written this condition wrong. It should be left equals to mid plus 2 and right is equals to mid minus 1. Let me think why. Mm, because the right element current made and the next element is equal and the current made is even. That means, for example, the current made is at fourth position and the fourth and fifth position are equal. That means 0, 1, 2, 3 are equal. So the current and the next can be skipped. The current and the next can be skipped, not the previous. So, and in the other case, the mid is odd. The current and the next can be skipped, but we uh, we have to shift before it. So 0, 1, 3 is the current position. So 0, 1, 2. Out of those it occurs, so the mid has to shift one backward. Let's see if it's working fine now. Yes, it does. Let's submit. Yeah, so it's giving us a complexity of 100% and the memory is also good. So this is O of log n and O of one space complexity solution.